it through patiently. And you guys watch me carefully. Oh, here it is. Let me erase all this. Because I got back in chapter 7 to get that chapter 7 pretty much done. I will quickly close everything down. Philip, tell me, were there also some other formulas that I have not discussed yet besides the double angle? Did you see anything else there on that handout? Besides double angle, are there some others? Half angle. Were they listed for you? No, okay, so there must be on another handout that you don't have it. And that would be the last of the formulas. So I'll get that later on, not today. Now, here goes, don't get angry. This connects with what I want to do. I've got a reason for everything we do here. We're going to redo this problem. This is Professor, redo this problem, it'll be 320. How many time to go? Look how much time it took us to get that answer of, I think the answer finally came out to be 63 or 65, right? Let's redo it. And take us into chapter 7. That's what I did. Now you said, wait, Professor, you mean you're going to redo it? Quicker way to do it. And get that same answer? Here we go, guys. Keep in mind what they get. Here's the problem here. I know it's a little messy. Here's the original problem. And they give me inverse tan is 4/3. That means angle A is out there somewhere. June's already found this measure. But there's an angle out there whose tan is 4/3. And it's in quadrant 1. Now, to go into chapter 7 with that little bit of information I gave you guys yesterday, look at this. I can hold on. Let me, let's see, I got the red and the blue going. Yeah. Let me do this. Keep everything nice. Let me make a sketch of what's going on. So watch carefully. Now guys, in quadrant 1, we decided in quadrant 1 is going to be angle A. It looks something like this. And since I used red over there, I can put angle A in there. Now we set up angle B. I think we decided angle B was also in quadrant 1. And I think I was using a blue marker over there. I think it was blue for angle B. And let's say put something like this. And we mark this as angle B in blue. Those angles are located. Now, on the red one, this says its tan is 4/3. Now watch carefully, guys. This is nice to go into chapter 7 with this problem. Its tan is 4/3. Suppose I go ahead and drop a perpendicular on the sketch and form a right triangle. I think we had a chance to discuss right triangles yesterday. Drop a perpendicular, form a right triangle right here. And I'm going to go ahead and do it here also, we need shortly. You guys who may have been out yesterday, we did some of this work in class. Right angles, right triangle. And again, going back, they gave me that tan A, this is tan A here, guys, is 4/3. But tan is, I know y over x. How, back from high school, were we thinking of it? Remember yesterday? I give you another definition from high school for tangent besides y over x. It could also be thought of as what? Opposite over adjacent. I think we did that, didn't we, yesterday? Yes. So if I can show that the opposite over the adjacent here is 4/3, then I have a sketch to show. Why not? This is the opposite, and this is the adjacent for angle A. If I put this over this, I'm supposed to get 4/3. Well, why not put 4 here? 3 there. That's opposite over adjacent. That's an illustration of tangent. Now, if I do, though, the hypotenuse, c squared is equal to a squared plus b squared for a right triangle, and you know how to use Pythagorean theorem. Thank you. I'll just go and jot down. It is 5. If you use c squared is equal to a squared plus b squared, Pythagorean theorem, you get 5. The trouble is, we would like that to be, because we are more accustomed to this. We prefer that 5 to be a what? If we can. A 1. We're so accustomed to that unit circle. You can change it to a 1. Quickly. If you do this. Divide this by 5. Put it in black. Divide this by 5, and that changes that down to a 1. But if you do it there, you got to do it here. And here. Then we'll come back to it. Now it's more like a unit circle for us. Angle B, they told me angle B, the information right here it was, put it up here. The cosine is 5/13. You guys, let's do the same thing here on cosine B, 5/13. Cosine, someone remind me from the high school definition? Is adjacent over the hypotenuse. That means 5 goes here, hypotenuse 13. There's the cosine, wasn't it? Yeah. You guys agree? Now, can someone tell me if I use this Pythagorean theorem and put those numbers in like we would in high school, can you tell me what the other side is? 12. Thank you. We have 12. 13 squared is 169, and then 5 squared plus 12 squared, which is 144, will give you 169. Checks. Guys, there's the illustration to show you those two angles. Now they asked me to find, now look at this lengthy thing it took me to find. But they asked me to find this, cosine, here we go. We said, eventually came out to what, cosine A, oh help me, I don't want to mess up now. A minus B, wasn't it? I think it was. And we said it's cosine A, cosine B, plus sine A, sine B. That's what we had right here in that lengthy presentation, which made all kinds of sense, but let's see what happens here. Cosine A, now since I have triangles and not using properties, like Alina gave me that wonderful property, without using properties, now we're going to use triangles. Can anyone tell me what cosine A is back here on the A sketch? And I could have left it, hang on, I could have left it. I don't see unit circle now. I could have left it as, this was 3, this is 4, we'll confuse anyone. This was 4, and this was 5. And cosine is, from yesterday's definition, what cosine is what? Adjacent over hypotenuse? Is that 3 over 5? Here. Next to it, cosine B, oh, I'm down here. Cosine B should be what? Adjacent over hypotenuse? What's that over there? 5 over 13. Gia, hang on just 1 second. Yes, Gia, go for it.
If you left the left-hand side as the 3, 4, 5 triangle, would you have to also leave the right-hand side as the 5, 12, 13?
That's up to you. I think I know what you're saying there.
Mm-hmm.
It's up to you. Now we'll see if this will work out. Sine A, I think I understood what you said there. Sine A, guys, back to the A sketch, sine is opposite of hypotenuse. In this case, that would be what, 4 over 5? Yes or no? Is it 4 over 5? You guys are scared, is it? And sine B, oh, we did cosine here. Yeah, sine B. Here's B, sine for the right triangle from yesterday's what? Opposite of what? Hypotenuse. And that would be what? 12 over 13? This is 15 over 65 plus 48 over 65. That's 63 over 65 if my math is correct. Was that the answer we got earlier? I didn't ask anyone to time me. I know it probably took a good 10 to 15 minutes. The way I approached this with the properties were there. Not that long here. You see the benefit? Of referring to a triangle and read through the problem, think about triangle A, triangle B, and just put the numbers in. Make sense? Is it much easier? You get that, then use those properties? So I thought I'd bring that in, and that's where we are now. We're in chapter 7. That's why I did this. Guys, any concerns? Gia, remind me again, what were you concerned about?
Oh, I think I figured it out.
You got it? You got it? Okay. Absolutely. Now, before I leave it, if we did do what I did, to make this a unit circle, don't mess up your notes, guys. I said you could divide everything by 5, you're back on the unit circle. Okay? Now, if I ask for the cosine of angle A, it's just the x, and the x was 3/5, right? If it's a right triangle, you place what? Adjacent over hypotenuse. Since I now have this as a unit circle, it's just the x. You can just directly put a 3/5 in there. Wow, does that help? See the little connection between the two? Now, I guarantee you, when I put one of these on the test, I've had some students who like this. They follow the properties. Makes much more sense to them. Go for it. Others say, Professor, can I use, if I give you an option, you use this? I get the answer in no time. Okay, we're using chapter 7. We're going to erase this. I had to point that out. Now, what I want to do is, and Phillips tell me, said, Professor, you're not quite finished with all the formulas. You still have a few, half angle? And we'll finish that up tomorrow. I'm more interested in getting that chapter 7 here. Guys, let's call this part 1 over here. Yes, solving triangles. Please tell me, you guys were with me yesterday, did you? Did we get a handout that had something about triangles on it? Or not? No? There's nothing about solving a triangle? Okay. Whew! Hang on. I got tons of information here. But I don't know whether we actually need it right now. This is chapter 11. We don't need that. Oh my goodness, this is your test. You'll see this? This is your test for tomorrow. You'll see this? Sure, I can do it. That. Oh. You haven't seen this.
It's a sign for
Oh. We're instructors just out doing. Hang on. Yeah. We're ready. This will be basically chapter 7 done. I can get through this. Mr. Park, you want to help me out?